6.8. The objective of this lesson is to use the multiplication principle to find probabilities. I will use a simple example to illustrate what the multiplication principle is. Let's take a coin, for example. The side with the heads is called heads. The side with a golden eagle is called tails. Okay, let's take a look at the tree diagram to the right. When you flip the first coin, the only possible outcomes are a heads or a tails. When you flip the second coin, you could have a heads with a heads or with a tails, or tails with heads, or tails with tails. So that comes out to be a total of 4 possible outcomes. So we can conclude that for the first coin, there are 2 possible outcomes. And for the second coin, there are also 2 possible outcomes. And if we multiply 2 by 2, we get 4, which is the same as the 4 here when we use the tree diagram. Okay, so this illustrates the multiplication principle. Now I'm going to explain how to use 2 cubes to show the multiplication principle. Imagine rolling a blue and a red number cube. Use the multiplication principle to find the number of different possible outcomes that are possible. Okay, so think about this red cube. What happens after you roll it? Either you land on 1, 2, 3, 4, 5, or 6. So there's a total of 6 possible outcomes for the red cube. And the same holds true for the blue cube, 6. And by the multiplication principle, 6 times 6, you get 36 total number of possible outcomes. So we can summarize the multiplication principle in this box here. If one event, okay, let this red cube be the first event, can occur in m ways, and for each of these ways, a second event, so let the blue cube be the second event, can occur in n ways, then the number of ways that the 2 events, so these 2 events, can occur together is m times n, which equals mn. The multiplication principle can be extended to 3 or more events, meaning, let's say if you rolled 3 coins, 1, 2, 3, 3 coins, okay, then you would have 2 times 2 times 2, which equals 8 possible outcomes. Okay? Guided practice. Using the multiplication principle, how many different outcomes are possible when you flip a coin and roll a number cube? Okay, you know that when you flip a coin, you either get a heads or a tails. So that equals 2 possible outcomes. And when you flip a coin, you either get 1, 2, 3, 4, 5, or 6. So that's a total of 6 possible outcomes. And by the multiplication principle, you would just do 2 times 6, which equals 12. So that would be a total of 12 possible outcomes. Part B. Find a probability using the multiplication principle. Combination lock. So a combination lock is what we have here in this little picture here. A combination lock has 40 numbers on its dial. So this part would be the dial. To open the lock, you must turn the dial right to the first number, left to the second number, then right to the third number. So basically, you need to have 3 numbers to open the lock. You randomly choose 3 numbers on the lock. What is the probability that you will choose the correct combination? Okay, first you need to find the number of different combinations by using the multiplication principle. So you know the first time you turn the dial right for the first number, there are a total of 40 possibilities. And when you turn the left for the second number, there's another 40 possibilities. And when you turn the dial to the right again for the third number, there's another 40 possibilities. So you need to multiply 40 times 40 times 40 to get the total number of possible outcomes. So 40, 40, 40, you get 0, 0, 0, and then 64,000 possibilities. Then you need to find the probability that you choose the correct combination. And there's only one chance that you'll get it right. So I will need to put 64,000 in the denominator, because remember, a probability is represented by the number of favorable outcomes in the numerator over the total possible outcomes in the denominator. So there's only one possible chance of getting it right. So the numerator has to be 1. So the answer is, the probability that you choose the correct combination is 1 out of 64,000. And that's it for our lesson.